This is the second video for section 6.1. In this video, we're going to mainly focusing on the inverse sine function. So at the beginning, I have the sine function graph period drawn on the screen. So you can see it passing through the vertical line test. However, talking about more than one period, it is not a one-to-one function. Sine function cannot have inverse function because it's not one-to-one function. Not one-to-one function cannot really have inverse function. You can thinking about you go from point, you have two numbers like x1 and x2, both go to the same position. For example, y, just using arbitrary symbols. Then when you go to the return trip, if you start from y, you're not sure which direction are you going to return back to. Am I going to return back to x1 or return back to x2? Because both number can be the possible landing point. So for that reasons, not one-to-one function, we don't really have inverse function. Not only sine function, all the trig functions have the same property because those are periodic functions. It will repeat itself even within the one period. Still not a one-to-one function. So what we have to do for sine function in particularly is we need to making sure my original piece or my original function, I'm going to shrink it, I'm going to trim it to a particular region that is nice, has its own identification for the sine function for this case, and it's going to helping me to find the inverse function. To making it happen, we can see that majority of the for the sine function is going to range from -1 to 1. So I do need to have the entire range from -1 to 1. Number two is I need to making sure after I trimming it, my function is still a continuous piece. So it's not break, it's one piece. And then the next part is because we're talking about, or because all the trig function is coming from the unit circle, we always like the first quadrant, because first quadrant is pretty much the most popular quadrant. Combining all three pieces, so we want the first quadrant. So here are the first quadrant. When we're talking about the first quadrant, it's already having the piece from 0 to 1. Then I do not need to have my second quadrant. Here is the second quadrant. I do not need to have my second quadrant because second quadrant repeat the same from 0 to 1. I want to have the quote-unquote third quadrant because that piece have 0 to -1. But if I do have it, the function is going to break. It's not going to be continuous, so it's a nice function. So what can we do is we're going to pick the fourth quadrant, but not this fourth quadrant. It's the fourth quadrant from the other period. So this highlighted piece is the trim piece we are interested in. So I'm going to erase everything else. This piece of the original sine function is the one we want, and then we can using it is a one-to-one function. We can use it to find the inverse function, the inverse sine function. Okay, so we have 3 points. Or 3 easy point we can locate it. The first one is pi over 2 comma 1. The second point is 0, 0. The third one is negative pi over 2, negative 1. And then we can use those 3 points to flip it to have the inverse graph. So pi over 2, 1. What becomes to 1 pi over 2. So 1 pi over 2. And then 0, 0, still 0, 0. And then negative power 2 and negative 1 what becomes to negative 1 negative power 2. Negative 1 negative power 2. And then connecting them. Okay, so this is the graph for the inverse function. For inverse trig function, we have two ways to kind of representing it. The first one is the traditional inverse symbol, the -1 on the top, or we can say it out loud, which is the arc sine x. So both have the same meanings, sine inverse of x or arc sines, both talking about the inverse function of the sine. Combining the discussions we have, so for inverse sine function, we're using the symbol either sine inverse of x or arc sine of x. That means sine of equal to x. Do have a restriction for the y. Y is going to be between negative pi over 2 and pi over 2. Since we're talking about this one, I'm just going to also write down the domain and range. So from this definition, we can have the range first. The range for the inverse function is negative pi over 2 to pi over 2, which is corresponding to this part. And also the one we've been talking about. The domain for the inverse function is going to be between -1 to 1. The inverse function is an odd function, meaning sine inverse of negative x equal to negative sine inverse of x. So example 1, I want to find the value of the following number. The first one I have is y equals arc sine of square root 3 over 2. Arc sine means this is the inverse function. Meaning sine of y equals to x. So I can rewrite it as sine of y equal to square root 3 over 2. From the unit circle, we know y is going to have a reference angle of pi over 3. Positive in quadrant 1 and quadrant 2. Okay, why I need to talking about this one, why I can just say like y equal to pi over 3, is because we do need to considering the quadrant. We have quadrant 1 and quadrant 2, but we also need to considering the range of the y. From negative pi over 2 to pi over 2, that means is my angle, my y can only be in between those two, in between this range. So for this case, quadrant 1 and quadrant 2, my y has be in quadrant 1. So y is going to be equals to pi over 3. Okay, So you can try, or we can see the second one, so you can see why I need to talking about the range, the quadrant. So my second one is sine of y equal to sine inverse of -1/2. So according to the definition, I can write as sine of y equal to -1/2. So 1/2, first 1/2 tells me y has a reference angle of pi over 6. Negative means in quadrant 3 and quadrant 4. I cannot have quadrant 3, so it's going to be in quadrant 4. However, in quadrant 4, I cannot have y equals to 11 pi over 6, which is in quadrant 4. Yes, sine of 11 pi over 6 will give me -12, but that is not in the range of negative pi over 2 to pi over 2. So I still need it to be in the quadrant 4, but not 11 pi over 6 is the backward direction. So this is the wrong one, which is negative pi over 6 is still in quadrant 4. And that is the correct answer. And that's the only one correct answer. So you can see from here, when we're talking about the inverse values, we have only one answer. It's not going to be like a previous one, depending on the circles we have, how many repetitions we have, how many possible answers we can have. We do need to make sure we have everything, or we have a particular one in particular region. Here, when we're talking about inverse functions for the trig ones, we only have one correct answer.